Having discussed the antigen and the antibodies individually, now let us go on to their reactions. So we now study antigen-antibody reactions, which are of two types: precipitation and agglutination. So as I've told you, this is an interaction of an antigen-antibody, antigen-antibody, but what type of antigen? So for precipitation reactions, we have a soluble antigen, and for agglutination reactions, we have a particulate antigen. Remember, P is not for P, my favorite mnemonic which I use everywhere in path and in micro. So P is not for P. For precipitation, will you add particulate antigen? No, you will add soluble antigen. And for agglutination, you will measure the particulate antigen. So let's start one by one. I'm starting with precipitation reactions, and they can either occur in a liquid media or they can occur in a gel. So I'll first take up the ones that are occurring in a liquid media, and the first one is when antigen and antibody will meet, it will form a ring. The second one is that when the antigen and antibody will meet, it will form chota floccules. So when I say that an antigen over here and an antibody over here, they are gonna meet in this zone, that is where a ring is formed. Can you see a ring over here? So that becomes a ring precipitation reaction. How simple is it? There's an antigen, there's an antibody, they have combined, they have made a ring, and I get a ring test. I mean, nothing could be as easy as this. So is there any test that you've studied? Yes. We have studied in bacteriology, A for A, there is an Ascoli's ring precipitant test for anthrax, and there is a streptococcal Lancefield grouping. I hope you remember from your streptococcus chapter that streptococcus Lancefield grouping is for the beta hemolytic streptococcus. And which antigen am I talking about? We are talking about the C antigen, the carbohydrate antigen is what we are speaking about. So remember, the streptococcal Lancefield grouping for, of course, streptococcus, and Ascoli's test for anthrax, both of them are going to result in the formation of a ring. They are ring precipitation reactions. Is there anything that I have to be a little cautious about? Yes, there is a hypothesis known as the Marek's hypothesis. What is Marek's hypothesis? It says that when your antigen and your antibody are going to be almost similar in amount, that is when a ring will form. So can I say that this becomes the ZOE? This becomes the zone of equivalence. When the antigen and antibody are in the same amount, you can see that the precipitant formed is at its maximum best. Means anything less or more is going to create a problem. So if there is excess of antibody, do you see any precipitant forming? No. If there is excess of antigen, do you see any precipitant forming? No. So what are these known as? When there is excess of antibody, this is known as the prozone phenomenon. A lot of students ask me, what is prozone phenomenon? That is when antibodies are in excess. Lattice nahi banega. The lattice, the antigen-antibody reaction will not occur. When antigen is in excess, that is known as the post-zone phenomenon. That is known as post-zone phenomenon. So now let me show you another picture of how it's going to come. So look at this. When they'll say that the antigen and the antibody have become equal in amount, you will say jab equal hai, that means this is the zone of equivalence. The lattice has formed so beautifully, you will see the ring. If I on the other hand say that there is too much of antibody in the sample, there is way too much of antibody, that is what I have said. If antibody is in excess, what phenomena is it? It's a prozone phenomena. On the other hand, if I say that there is excess of antigen that is present, if there is too much of antigen that is present in the situation, then you say this is a post zone. Many students get confused. Pro and post mein kya hoga? So dekho, pro sounds earlier, post sounds later. Antibody and antigen में से B comes earlier and G comes later. ठीक है? So when antibody is in excess, it is a prozone phenomenon. When antigen is in excess, it is a postzone phenomenon. Go in an alphabetical order. This concept was known as Marek's hypothesis. Now what have we done? In liquid, I have already finished the ring test. I'm going to go on to the flocculation test. So what are the flocculation tests that you have to know? That now instead of making a ring, whatever antigen and antibody will form, that will basically form a floccule. So either that could be you could see the floccules on a slide, or you could see the floccules in a tube. So देखो, Tube is known as the Cahen test and slide is known as the VDRL test. But both of them are for the same thing. Slide and tube, ye VDRL and Cahen, what are they for? They are for Treponema pallidum, basically syphilis. They are for Treponema pallidum, that is going to be syphilis. But what we use more commonly is of course going to be the VDRL. So please remember the VDRL is very famous question. VDRL is which kind of immunology reaction? It is a slide flocculation test. It is a slide flocculation test, as it is Rutlo, slide flocculation test. So coming back, what all have we studied up till now? I told you that we had to do liquid media. Either you made a ring in that antigen antibody ke liye. Ring mein, do a quick summary with me. Ring mein you had two things. Either you made an Ascoli's ring precipitant test for which organism? A for anthrax. Or you did a streptococcal Lancefield grouping. So these were the two that you had put under the ring precipitation. For flocculation, you said, ma'am, you could make slide flocculation, which example you gave was VDRL. And you could do a tube flocculation where you gave an example of the Cahen test. So these two are certainly done, but you were doing all of this in a liquid. Now it's time to change into a gel. Gel means what? Agarose gel. So you're going to use a 1% agarose gel over here. And now comes the real thing. I've seen most students find a problem here. So listen to me carefully. Precipitation reactions that happen in gel media. Before I go on to those, you need to understand two definitions. What is diffusion and what is dimension? So if I tell you, I have done the whatever test I'm doing, I have done it in a test tube. If I say I've done it in a test tube, you'll say, ma'am, one dimension mein kara hai. If I say I have performed it on a slide, you will say you have done it on 2 dimensions. How do I learn? So the way you write test tube, it looks like one dimension. The way you write slide, isko flip karo, it looks like a 2. So simple. Test tube means 1 dimension. Slide means 2 dimension. Many people also learn कि test tube ऐसा 1 की तरह बनता है and slide has length and breadth. तो slide में 2 dimensions and test tube में 1 long dimension. Simple. Test tube 1 dimension, slide 2 dimension. Dimension का story tick mark. What is diffusion? Single diffusion. What is single diffusion? When only one thing is moving. When only the antigen, for example, this is an antigen and an antibody. If only antigen is moving, one person is diffusing. So this is single diffusion. If antigen and antibody both start moving, that is then known as double diffusion. So remember, if one is moving, single diffusion. If both are moving, double diffusion. You've understood the meanings of diffusions and dimensions. Let's do a very quick recap. Test tube matlab which dimension? 1 dimension. Slide matlab 2 dimension. If only antigen is diffusing, single diffusion. If antigen antibody both are diffusing, double diffusion. Now you must have heard of a lot of tests, but I know there are 4 tests. ठीक है, दोनों उनका नाम याद करना is like humanly impossible. They're such difficult ones. But our point, the purpose of my lectures is to make those humanly impossible things a little possible for you. So what is that OOTD? Now you're all Gen Z people, guys. You know what is OOTD? Outfit of the day. So I'm going to use your Gen Z Instagram slangs and hashtags into this particular slide. But now I know that as medicos, our life does not revolve around OOTDs. Unfortunately, as medicos, we are so much into studies. Our life is more into topic of the day, mnemonic of the day, image of the day. I also keep having these series on, on social media, IOTD, TOTD or MOTD, and it's quite sad that where our counterparts and colleagues who are non-medicos are doing OOTD, we are in an altogether different world. So today we will also do OOTD, but not outfit of the day. I'm going to use a tube. So tell me, tube is what dimension? Tube, T1, single long tube. So you are basically talking about 1 dimension, 1D. So when you're having a tube and you have 1 dimension, now you will say, ma'am, dimension to fix ho gaya. You are doing the test in 1 dimension. Now you can play with the diffusion. Either you're going to have a single O, so matlab you are going to have a single diffusion in 1 dimension. Either you're going to play with the test where there is single diffusion in 1 dimension, or you're going to play with the test where there is going to be double diffusion in 1 dimension. So simple, 1 dimension to fix ho gaya. Test is being done in a test tube. Single diffusion means only antigen is moving. Double diffusion means antigen and antibody both are moving. So when it is single diffusion, it is known as the Auden test. It is known as the Auden test. The O for Auden test. But when it is double diffusion, so ma'am, double words aana chahiye. That is known as the Oakley-Fulthorpe test. That is known as the Oakley-Fulthorpe test. I'll repeat it. Now if I write this in the form of a sentence, so what they'll do in the exam, they will say, can you tell the meaning of what is single diffusion in one dimension and what is double diffusion in one dimension known as? And you'll be like, okay, hang on. As soon as I know that they're talking about one dimension, you'll say, arey, one dimension matlab they're talking about the test tube. They've asked me about the OOTD mnemonic. So if they've asked me single diffusion in one dimension, I will mark as Auden test. If they've said double diffusion in one dimension, I will mark Oakley-Fullthorpe test. Have a look at the pictures now. See, it's in front of you. Single diffusion in one dimension, double diffusion in one dimension. One dimension matlab the test tubes are in front of me, correct? Single diffusion means who is moving? Only the antigen is seen moving. Only antigen is moving. This means this is the Auden test. And if I see the antigen and the antibody both are moving, that means it is double diffusion. That is going to be Oakley-Fullthorpe test. Simple. If you see only antigen moving, Auden. Antigen and antibody dono move kar rahe hain, do words use kar lo, Oakley-Fullthorpe test. In case you don't want to put so much of logic into it, Auden is sounding like ek din. Everything is ek. One diffusion, one dimension, one day. Okay, one diffusion, one dimension, one day. So that is Auden, and the other one becomes a double diffusion in one dimension. So now you're done with the one dimension. You're done with the test tube wala thing. So now whatever is left is going to be the two dimension, means slide wala thing. Okay, so under this, the first one that you have, you'll say, ma'am, now we are going on to two dimension. Two dimension means now you're going to deal with a slide. And अब फिर से वही है. Now you're going to talk about the diffusion. The diffusion can either be single diffusion or double diffusion. We'll start with single diffusion. Single diffusion is known as radial immunodiffusion. That is going to be RID. RID is going to have a radial immunodiffusion. So if you read the word, I'm going to pick up the same alphabets. Radial immunodiffusion. Radial matlab, I'm going to see a picture which is having a circle, because circle has a radius, hai na? So I'll see a radius wala photo, and if I pick up the eye, it's looking like 1. So it is what diffusion? Instead of immunodiffusion, can I say it is one diffusion? And ऐसे slide में हो रहा है, तो it has to be a two dimension. So now you know कि ठीक है, two dimension तो slide you know. You just wanted to know single diffusion or double diffusion. So you'll say अच्छा radio immunodiffusion में तो one diffusion word is anyway coming. So it becomes a single diffusion. Means who is going to move? Single diffusion means only the antigen is going to move. So let's have a look at it. What did they do over here? They took a gel, or basically you said now all of these are gel based. So they took an agar gel, and in that agar gel they have already added an antibody. After that, there are certain wells that are present in which they are going to add the antigens. And who is going to move? Only the antigen is going to move. Single diffusion है ना, so only one person can move. Only the antigen is going to move. तो antigen move करेगा. Once it will meet the antibody, there is going to be a reaction. So you can have a look at this. You can see over here that as there were rings formed, or you can say there were precipitin arcs formed, precipitation reactions हुआ, antigen antibody reaction हुआ, but we are even measuring the diameter. Every ring that is formed, I am measuring the diameter. So this is just not to know antigen antibody reaction. This is also going to give information about the concentration and the subclasses. It's also going to give concentration and subclasses of different antigens and antibodies can be given over here. Please note, this is also known as, only for INI-CT I'm telling you, this is also known as the Mancini's method. This is also referred to as the Mancini's method. So I'm repeating once again, radial immunodiffusion. Radius will remind you कि ये कुछ slide में हुआ है. Slide मतलब it's a two dimension, and immunodiffusion मतलब one diffusion. It has occurred in single diffusion. So what am I left with now? Now I'm left with DDDD. Now ma'am, you are left with two dimension and double diffusion. What did I say? Two dimension and double diffusion. Is it sounding like D, D and two D's over here? DD. Does it remind you of any cartoon? Remember Dexter? Have you guys seen Dexter cartoon? Dexter की एक sister है, that is DD, है ना? So when DD comes into Dexter's laboratory, can Dexter work? No, Dexter is like too panicky, and DD breaks everything in his lab, all his test tubes and experiments. So how I have learnt it is that when DD will come in the laboratory, please note that this is gonna be ouch. Everything is going to break. DD is going to break everything. So double diffusion in 2 dimension, D is known as the outer Loney test. Ouch. DD is going to be outer Loney test. And why did I say DD? Because ye to DD to is telling you double diffusion 2 dimension, DD. And I've told you that DD has come to ouch hoga, that is outer Loney test. But why did I write EEDD? Because an example of the outer Loney test is the LX gel precipitation test that you do for Corynebacterium diphtheria. So now everyone write DD with me, which basically tells you that when you write DD is coming, firstly you will say that ma'am, all the D's have to come. This has to be a double diffusion in 2 dimensions. Then when you're saying DD is coming, so ekdam se I'll be like, okay, ouch, everything is going to break. This is the outer Loney test. After that, you are left with the E's. So now I know we are dealing with the LX gel precipitation test over here. Let me come back and show you the picture. I am saying it is a double diffusion. Everyone is going to diffuse. Antigen will also diffuse. Antibody will also diffuse. And I can see over here, I have kept an agar plate with a lot of antibodies. Okay, and in these wells, if you look, I have added antigen number 1, then I have added antigen 2, I have added antigen 3, I have 4, 5, different antigens I have added. Why? Because I realized that all of them start coming out. Antibody ke response mein, all of them start diffusing. Sometimes I will see that these, like this antigen from here and this antigen from here, they were moving and they ended up making an arc. This antigen from here and this from here, they ended up making a continuous arc. Matlab this and this antigen is the same. When you go and hug someone, you're best friends with them. You are very similar. That is when you go and hug someone. So if the arcs have hugged each other, this means this and this antigen is identical. But if you go and fight with someone, if you go and have these intersecting line, matlab ye aur ye antigen same nahi the. They were non-identical. And on the other hand, you kind of give a formal hug. Kind of hug, kind of war. Kind of hug, kind of war. Matlab partial identity. That is known as spur. So repeating once again, if you get a precipitin line which is a common arc, matlab they are identical. If you get as a cross, matlab the antigens are non-identical. And if you get a kind of cut and kind of meet, what did I say? Kind of cut and kind of meet, that is a spur formation, that is a partially identical. So let me ask you, yahan pe kya dikh raha hai? What do you want to take this? Yahan pe what kind of an arc is forming? You will say, ma'am, mujhe to this is looking like a continuous arc. What do you want to say? Are these antigens in these wells, are they identical or non-identical? Continuous ho raha hai, so they are identical, right? If they would have been cutting like this, they would have been non-identical. And if they would have been like partially cutting like this spur, they would have been partially identical. This is known as the DDDD test, outer Loney test, LX gel precipitation test. And that means that on that note, you have finished finally with all of your gel precipitation tests are over. Yes, everyone's okay with this. Now what do we move on to further? Now you say, ma'am, isme to bahut zyada time lag raha hai. Before that, I want all of you that please do a quick revision with me, because many students are unable to, memorize this only. So let me start. When I say, first I'll start with what? I'll start with OOTD. What is OOTD? Means I'm using a test tube. A test tube means I'm using a one dimension. So single O means I can have a single diffusion. What do you want to call single diffusion? 1, 1, 1, 1. You want to call it an Auden test. What do you want to call the double diffusion? Double diffusion you want to call as the, yes, the two names should come, ma'am. That is Oakley-Fulthorpe test. Okay, Oakley-Fulthorpe test. This was about the one dimension story. Now tell me about the very easy, the two dimension story. So two dimension may be same. Either you're gonna have a single diffusion in 2 dimensions, or you're gonna have a double diffusion in 2 dimensions. So tell me, if you have a single diffusion, so 2 dimension kya hua? Slide. Ma'am, this will also occur on a slide. This will also occur on a slide. So single diffusion matlab radial immunodiffusion, Mancini method, immunodiffusion, one diffusion, whereas double diffusion in 2 dimensions is going to be ouch, that is outer Loney test. Simple. Auden, Oakley-Fulthorpe, RID and outer Loney.